Hi everybody, once again on behalf of TM Tutorial, I welcome you to this episode of my tutorial video series. As you know, TM Tutorial is a platform that provides online tutorials as well as provides tutorial videos on a range of subjects including pure economics, financial economics, corporate finance, financial management, financial accounting, cost and management accounting, and quantitative technique. Right? Now, the subject of this video is microeconomics and the topic is theory of demand. It is part 2 of theory of demand, on which we shall focus on price elasticity of demand. In part 1 of theory of demand, that is on my earlier video on theory of demand, we have discussed what is demand, what are the factors that influence demand, what is the law of demand, and what is demand function. For a quick recap, demand is the desire to have something backed by adequate purchasing power. Mere willingness to have something is not demand. When the consumer is willing as well as able to purchase something, then the consumer is said to have demand for that commodity. Right? The factors that influence demand are price of the commodity, prices of related commodities, that is substitute goods and complementary goods, income of the consumer, tastes and preferences of the consumer, and many others, so similar factors, the customs, habits, etc. So among them, most important factors that influence demand are price of the commodity, number 1, second, income of the consumer, and third, prices of the related commodities. Now, elasticity of demand can be of a number of types. Number 1, price elasticity. You can write EP or ED, both are accepted. Number 2, cross elasticity. You can write EC. Number 3, income elasticity. You can write EY. And elasticity of substitution. Right? So price elasticity means the responsiveness of quantity demand of a commodity with respect to change in price. Cross elasticity means responsiveness of quantity demanded of one commodity with respect to change in price of another commodity. Income elasticity, this means responsiveness of quantity demanded of one commodity with respect to change in income. And elasticity of substitution is altogether different concept. It has nothing to do with price change or income change. Elasticity of substitution means the percentage change in ratio of consumption of two commodities with respect to percentage change in marginal rate of substitution. Now this video will focus on price elasticity, and we shall discuss cross elasticity, income elasticity, and elasticity of substitution in another video. Right? Now, as we know, we have discussed in earlier video the law of demand. Now what is the law of demand? Law of demand states the inverse relationship between quantity demanded of a commodity and price of that commodity, other things remaining constant. That means when price of a commodity falls, quantity demanded of that commodity increases, and when price of a commodity increases, quantity demanded of that commodity falls, with ceteris paribus assumptions, that is other things remaining same. And what are the other things? Other things means the other factors. Correct? Now in this video we shall learn price elasticity of demand. Price elasticity of demand this is responsiveness of quantity change with respect to change in price, other things remaining same. That means mathematically this is percentage change in quantity demanded divided by percentage change in price of the commodity. Right? This is equal to change in quantity demanded divided by original quantity demanded. Change in quantity demanded divided by original quantity demanded, and the whole divided by change in price divided by original price. This is equal to delta Q divided by Q whole divided by delta P by P equals to delta Q by Q into P by delta P equals to delta Q by delta P into P by Q, where P is equal to original price, delta P equals to change in price, Q equals to delta Q equals to original quantity and delta Q equals to change in quantity. Right? So price elasticity of demand is equal to percentage change in quantity demanded divided by percentage change in price of the commodity, that is delta Q by Q divided by delta P by P, that comes to delta Q by P, delta Q by delta P into P by Q. P equals to original price, delta P equals to change in price, Q equals to original quantity, and delta Q equals to change in quantity. Correct? Now I have to erase this part so that I can proceed further. I am facing lack of space, so I take liberty to erase this part. Okay. Yeah. Now I am drawing certain diagrams to show you the different degrees of price elasticity of demand. On x-axis we measure quantity, and on y-axis we measure price. Correct. Now consider these as the demand curve, a vertical axis, vertical straight line, parallel to vertical axis. On this diagram, consider a horizontal straight line demand curve. In this diagram, consider a steep demand curve. And here consider a flat demand curve. And on the last one, consider a rectangular hyperbola type of demand curve. Now we know price elasticity ED equals to percentage change in Q divided by percentage change in P. Correct? Now here you see there is no change in Q, that is percentage change in Q is 0. Here percentage change in Q is 0, right? So elasticity for a vertical straight line demand curve is equal to 0. Correct? Now come to diagram 2. This is diagram 1. This is diagram 2. This is diagram 3, diagram 4, and this is diagram 5. Now come to diagram 2. You see, different quantities are demanded at same price. Here, same quantity was being demanded at different price. That means there is change in price but no change in quantity. Here we see quantity is changing, price is remaining same. So that means percentage change in price, this is 0 in this case. So when the denominator becomes 0, the whole thing, the whole fraction, the value of the whole fraction becomes infinity. So here ED, price elasticity, is infinity. Something by 0 is infinity. Correct? Here you see, change in quantity demanded is lesser than change in price. This type of demand curve is called relatively inelastic. This is relatively inelastic. When it becomes a straight line, when the demand curve becomes more steeper, it reaches 0. Correct? So it is relatively inelastic. Now relatively inelastic means if it is less than 1. Correct? Come to diagram 4. You see, the change in quantity demanded is relatively larger than change in prices. For this shape of demand curve, elasticity is, this is called relatively elastic. Relatively elastic. It is greater than 1. And in diagram 5, where the demand curve is rectangular hyperbola, in rectangular hyperbola, if you draw different rectangles on different points of the curve, the area of all the rectangles will be same. Here, this is unit elastic. This type of demand curve is called unit elastic. Here, ED equals to 1. So we see broadly there are 4 shapes of demand curve, and in accordance with the shapes, the elasticity changes when the demand curve is vertical straight line and parallel to y-axis. Price elasticity is 0. Why ED is 0? Because there is no change in quantity demanded, and in the formula, percentage change in quantity, percentage change in Q becomes 0. So 0 by something is 0. So ED is 0. In diagram 2, different quantities are being purchased at the same price, that means there is no change in price, only quantity demanded is changing. Since there is no change in price, so in the formula, the percentage change in P, that will be 0. So when the denominator of a fraction becomes 0, the whole fraction becomes infinity. So here price elasticity is infinity because it is something by 0. Here it was 0 by something. In this case, diagram 3, we have drawn a demand curve which is not vertical straight line but relatively steeper. Here the elasticity is relatively inelastic. The price elasticity of demand is relatively inelastic. That is, proportionate change in quantity demanded divided by proportionate change in price is less than 1. Here we have drawn a flatter demand curve, not horizontal straight line but a bit flatter related to this steep demand curve, and we see that here proportionate change in quantity demanded is more than proportionate change in price. That is why price elasticity becomes greater than 1. Correct? And in diagram 5, we have drawn a rectangular hyperbola demand curve, and we know the characteristics of rectangular hyperbola where the transverse axis, that is 2a, is equal to the conjugate axis, that is 2b. So we should not get deep into the nitty-gritty of rectangular hyperbola, but it is enough to understand that all the areas of all these rectangles, the rectangles drawn from different points of the demand curve, the area of all these rectangles are same. In this case, the proportionate change in Q is exactly equal to proportionate change in price. So price elasticity is equal to 1, that is called unit elastic. So we get price elasticity 0, price elasticity infinity, price elasticity relatively inelastic, that is less than 1, it is less than 1. Here in this type of demand curve, that is a flatter demand curve, price elasticity is relatively elastic, that is greater than 1, that is proportionate change in quantity demanded is more than proportionate change in price or percentage change in price. So the price elasticity is greater than 1. And in case of the demand curve, the shape of which is rectangular hyperbola, the proportionate change in Q is exactly equal to the proportionate change in price. So the price elasticity is equal to 1. Correct? Okay. In diagram 1, price elasticity is 0. In diagram 2, that is horizontal straight line parallel to x-axis, when the demand curve is horizontal straight line parallel to x-axis, elasticity is infinity. When the demand curve is vertical straight line parallel to y-axis, elasticity is 0. When the demand curve is steeper, relatively steeper, elasticity is less than 1. When the demand curve is relatively flatter, elasticity is greater than 1. And when the demand curve is rectangular hyperbola, then elasticity is equal to 1. Correct? Yeah. So I am erasing this part so that I can proceed further. I am erasing these diagrams because I have to draw many more diagrams. Okay. Now, in this section, we shall try to understand relation between slope of the demand curve and elasticity. The first thing you must remember that ED is not equal to slope. Price elasticity is not equal to slope of the demand curve. Price elasticity relates two percentage changes, that is, one is percentage change in quantity, that is in numerator, and percentage change in price, that is in the denominator. But slope of the demand curve are ratio of two absolute figures. When you draw a straight line demand curve, this angle is the slope of demand curve, that is delta P by delta Q. Slope equals to delta P by delta Q when we measure quantity on x-axis and price on y-axis. Sorry. Okay. Now I am going to draw two diagrams to demonstrate that when slopes are different, elasticity can be same, and when elasticities are different, slope can be same. Okay. So I am erasing this one because I have to draw two more diagrams. In this diagram, different slopes but same ED, and here I am drawing the diagram where we will find different elasticities but slopes are same. So it is quite understood that when you are talking different slopes or different elasticities, same slopes, same elasticity, this means that we are talking about two demand curves. So first, in this diagram, I will draw demand curves with different slopes, and I will show that elasticities are same. On x-axis we measure quantity and on y-axis we measure price. Now let AB and AC, these are two demand curves, straight line demand curves. Correct? Now let this be point M. Please watch very carefully. Now we draw a line parallel to x-axis on AB and AC. The line cuts AB at point R and AC at point S. Now in my earlier video, actually I have dedicated one full video on point elasticity of demand, because point elasticity of demand is a very complex thing and needs geometrical explanation. So I would request you to watch that video where I have exclusively discussed only point elasticity of demand. So for a quick recap, point elasticity on any point is equal to lower segment by upper segment. This is the lower segment and this is the upper segment. So elasticity at this point equals to, say, A, B and this is C. The elasticity at A equals to lower segment, that is AB, by upper segment, that is AC. Once again, I would request you to watch that video where I have exclusively discussed point elasticity of demand. In this video, it is enough to understand that point elasticity is at any point on the demand curve is equal to lower segment of the demand curve divided by upper segment of the demand curve in the context of the particular point. Correct? So ED at R, point R, that is on AB, on demand curve AB, is equal to lower segment by upper segment, that is RB by RA, now RB by RA, this is R. RB by RA equals to OM by MA, that is the property of right angle triangle. What is the property? In right angle triangle, if you draw a parallel line parallel to the base, then the line cuts the hypotenuse and the perpendicular in the same ratio. That is, if RM is parallel to OB, then this by this equals to this by this. That is, RB by RA is equal to OM by MA. This is one property of right angled triangle. Therefore, RB by RA equals to OM by MA. Correct? Then ED at S, that is on AC, equals to again lower segment by upper segment, that is SC by SA. Now SC by SA, you consider this triangle AOC, this bigger triangle AOC. SC by SA equals to OM by MA, again the property of right angle triangle. OM by MA. Therefore, RB divided by RA equals to SC divided by SA. This means elasticity at point S is equal to elasticity at point R. So these two lines, two demand curves, have the same elasticities in spite of the fact that their slopes are different, because these angles are different. Angle ABC is greater than angle ABO is greater than angle ACO. So slopes are different but elasticities are same. Therefore, ED at S equals to ED at R. So slopes can be different but elasticities can be same. Okay. Now we draw another diagram where you will see how two demand curves of same slopes can have different elasticities. On x-axis we measure quantity and on y-axis we measure price. Let this be AB, this demand curve is AB, and let this demand curve be CD. AB is parallel to CD. Demand curve AB is parallel to demand curve CD. Correct? These angles are same. ABO equals to angle ADO. So AB and CD are parallel to each other. Now consider point K. Right? We draw a line parallel to x-axis cutting AB and CD. Let the line intersects AB at point L and CD at point, say, T. Correct? AB and CD are two parallel demand curves, straight line demand curves, and KT is parallel to x-axis and KT cuts demand curve AB at point L and demand curve CD at point T. Now consider elasticity at point T. Elasticity at T on CD is equal to lower segment by upper segment, that is TD by TC. TD by TC, right? Elasticity at point T on demand curve CD equals to lower segment, that is TD, divided by upper segment, that is TC. So TD by TC. Correct? Now in this triangle COD, this is a right angle triangle, therefore TD by TC equals to OK by KC. So this is equal to OK by KC. Correct? Elasticity at point T is equal to lower segment by upper segment, that is TD by TC, and COD is a right angled triangle, therefore TD by TC equals to OK by KC. This is property of right angle triangle, right? Now elasticity at point L here, elasticity at this point on demand curve AB equals to again lower segment by upper segment, that is LB by LA. Elasticity at point L on demand curve AB equals to lower segment of the demand curve divided by upper segment of the demand curve, that is LB by LA. Now consider this triangle AOB. AOB is a right angle triangle, therefore LB by LA will be equal to OK by KA. LB by LA is equal to OK by KA. Correct? Now compare KC and K. KC and K. KA is less than KC. This is KA, this much is KA and this much is KC. So KA is less than KC. Therefore, LB by LA is greater than TD by TC. Isn't it? If Ka is less than Kc, OK remaining same in the numerator of both the elasticities, OK remains same. And if Ka is less than Kc, Kc is more than Ka, then LB by LA will be more than TD by TC. This means LB by LA means elasticity at point L. So ED at point L is greater than ED at point T. So what we can deduce, that when two demand curves have same slopes, elasticities can be different. Here you have learned two demand curves with different slopes can have same elasticity. Right? This is the relationship between slope of the demand curve and elasticity, that is price elasticity. Okay. Yeah. So I have to erase this part so that I can proceed further. So with your permission, I am erasing this part. Correct? Now measurement of elasticities. There are different methods of measuring elasticity. Number one is proportional method. Proportional method is one we have just applied, that is percentage change in Q divided by percentage change in P. Number two is outlay method. I am coming to outlay method. Number three, arc method. Right? Proportional method, outlay method, and arc method. Now proportional method we have learned, that is percentage change in Q by divided by percentage change in P. Now what is outlay method? The outlay method states that when price of a commodity changes, how the expenditure changes. That is, the elasticity is measured according to change in expenditure. Say, for example, this is the demand curve. At price P1, the consumer is consuming Q1 units. As price falls to P2, consumer is consuming OQ2 units. So the consumer's total expenditure when price is P1 equal to area of this rectangle. So total expenditure or outlay. Total expenditure of the consumer, that is total revenue of the seller. Total outlay at price P1 equals to the area OP1, say this is C and this is D. OP1C Q1, OP1C Q1, that is OP1 price into OQ1 units, area of the rectangle OP1C Q1. And total outlay at price P2 equals to this area this is the total outlay at price P2. So total outlay at price P2 is equal to the area OP2 DQ2, OP2 DQ2. Correct? Now, as the price changes, the expenditure is changing. Now, if due to fall in price of the commodity, if total expenditure increases, then the elasticity is said to be more than 1. And if due to fall in price, total expenditure falls, then elasticity is said to be inelastic, less than 1. And if due to fall in price of the commodity, new total expenditure remains same as the old total expenditure, then elasticity is said to be unity, that is equal to 1. Let us take a numerical example to understand what is outlay method. Here we measure price in this column, and in this column we measure quantity, and here expenditure. Price is increasing from 1 to 2, 3, 4, 5 and 6. Okay. And quantity is falling 6, 5, 4, 3, 2, 1. This is the law of demand. When price is increasing, quantity demand is falling. Put differently, if price falls, that is, it goes from 6 to 1, quantity demanded increases from 1 to 5, 1 to 6. So what is total expenditure? Here it is 6, here it is 10, here it is 12, here it is 12, here it is 10, here it is 6. Now, as price has increased, listen very carefully. As prices increased from 1 to 2, total expenditure has increased. This means elasticity is less than 1. When price further increases from 2 to 3, quantity demanded increases. So ED less than 1. ED less than 1. When price further increases from 3 to 4, total expenditure remains same. So here ED equals to 1. When price further increases from 4 to 5, total expenditure falls from 12 to 10. So here ED is greater than 1. As price further increases from 5 to 6, quantity demanded falls from 2 to 1. So here ED is greater than 1. Correct? So outlay method gives us an estimation about the elasticity, not any numerical figure. If we put this data in another way, we will find the same thing. Suppose price is falling 6, 5, 4, 3, 2, 1. 2, 3, 4, 5, 6. We have put the same data in different way. Here we have shown that price was increasing, and here we see that price is falling. Here price was increasing, as a result quantity demanded was falling. Here price is falling, as a result quantity demand is increasing. Now expenditure 6, 10, 12, 12, 10, 6. So as price of the commodity has fallen, expenditure has increased. Quantity price fallen, quantity expenditure has increased. So ED greater than 1. See, here it was greater than 1. We have got the same result here. When price is further falling from 5 to 4, expenditure is increasing from 10 to 12. So ED is greater than 1. When price further falls from 4 to 3, expenditure remains same at 12. So here ED equals to 1. Same thing you got here. And when price further falls from 3 to 2, expenditure falls. So here ED is less than 1, and here also ED less than 1. So outlay method gives us an estimation about the elasticity of demand. Now if we draw expenditure and price in one diagram, then we will see such a diagram. Suppose we measure expenditure on x-axis and price on y-axis, then we will get such points. Say A, B, C, and this is D. As price, at this price, this is the quantity. As price falls, from here to here, expenditure increases. So A to B, elasticity is greater than 1. Now look at B to C. B to C. Price is falling from here to here. Say this is P1, this is P2, and this is P3. So price has fallen from P2 to P3, but expenditure has remained same. So this is E. Expenditure has remained same in between B and C, in spite of falling price from from P2 to P3. That is movement from point B to point C. Expenditure remains same. So here ED is equal to 1, and movement from C to D, that is when price falls to P4, from P3 to P4, expenditure falls from E to say E1. So a movement from C to D shows that expenditure has fallen from OE to OE1. So here elasticity is less than 1. We are discussing outlay method. Outlay method states that when price falls, if the expenditure increases, then elasticity is more than 1. If price falls, expenditure remains same, then elasticity is equal to 1. And when price falls, expenditure also falls. This means elasticity is less than 1. Right? Now we see that elasticities at different point of a non-linear demand curve are different. We have seen and we have discussed it in my earlier videos that elasticities of at different points on a non-linear or curvilinear demand curve are different, and elasticities at different point can be calculated by drawing a tangent on that point and then measuring the lower segment divided by upper segment of that tangent. This means for a curvilinear demand curve like this, elasticity at this point will be lower segment by upper segment. Elasticity at this point will be the lower segment by upper segment of the tangent. So in case of curvilinear demand curve, we have to draw a tangent on that point on which we want to measure the elasticity, and then we calculate the lower segment of the tangent divided by the upper segment of the tangent to find out elasticity at that point. Now it may so happen that in a curvilinear demand curve, elasticity at all the points are same. If we draw a rectangular hyperbola, I am erasing this part because I am facing lack of space, so I am erasing this part. In a rectangular hyperbola demand curve, quantity on x-axis and price on y-axis. This is rectangular hyperbola demand curve. You see, all the rectangles have equal area. This means elasticities at all these points are same. So when the demand curve is rectangular hyperbola, elasticities at all the points on the demand curve remain same. This is rectangular hyperbola. ED at all points remains same, that is constant price elasticity in case of rectangular hyperbola. And that is what is the value of that? The value is 1, because areas of all the rectangles are same. So elasticity is 1 throughout the demand curve. Correct? So this is all about outlay method. Now we come to the third one, that is the arc method. Arc method is very simple. Actually, when we measure elasticity at a particular point, we apply the formula delta Q by delta P into P by Q. Elasticity equal to delta Q by delta P into P by Q. Correct? Now, what happens when we are measuring elasticities to different points? Movement from here to here, that is from this point to this point, we find one elasticity, a particular value of the elasticity. And when we move from this point to this point, that is movement becomes like this, we find another value of elasticity. This is the reason we measure an elasticity taking an arc. Arc means a part of the demand curve in between these 2 points. This is an arc of the straight line demand curve. And in curvilinear demand curve, this is an arc. That is elasticity between 2 close points. Correct? So we just make a little bit change in the original formula, the proportional method formula, percentage change in Q by percentage change in P. What we do? We simply make these changes, that is delta Q by delta P. In place of P, we write P1 plus P2 by 2, and in place of Q, we write Q1 by Q2 divided by 2. Now P1 old price, P2 new price, Q1 old quantity, and Q2 is the new quantity. So we simply take average of the prices and the quantities, nothing else, and we find out elasticity under arc method. And another method is number 4. So I had forgotten. Now I remembered. That is point. Actually, since I have discussed point elasticity in another video exclusively point elasticity. Actually, I have dedicated that video to point elasticity because point elasticity is a complex topic and needs a lot of understanding. That's why I have made a separate video exclusively for point elasticity, and you should do well to watch that video. So another is point elasticity, that is the lower segment by upper segment. I have discussed how we can deduce that geometrically. So once again I would request you to watch that video. Right? Okay. So this video was part 2 of theory of demand, focusing on price elasticity of demand. There are different types of elasticities, namely price elasticity, cross elasticity, income elasticity, and elasticity of substitution. In this video, I have focused on price elasticity of demand, and in another video I will discuss cross elasticity, income elasticity, and elasticity of substitution. Now price elasticity is what? That is percentage change in Q divided by percentage change in P. That is the basic formula of price elasticity. Elasticity can be anything from 0 to infinity, and we have learned the shapes of demand curves for different degrees of elasticity. That is, what is the shape when it is 0, what is the shape when it is infinity, what is the shape when the elasticity is relatively elastic or relatively inelastic. And we have learned what are the methods of measuring elasticity, that is proportional method, outlay method, arc method, and point method. In proportional method, the formula is percentage change in Q divided by percentage change in P, and in outlay method, expenditure, the total expenditure is related to price instead of quantity, and if as a result of fall in price of the commodity total expenditure increases, then ED is greater than 1. If the total expenditure remains same, then ED is equal to 1, and if the total expenditure falls as a result of fall in price of the commodity, then it is less than 1. Correct? And we get a diagram like this, a movement from A to B, that is price is falling, as a result expenditure is increasing. On x-axis we have measured expenditure, and on y-axis we have measured price. So a movement from A to B means that expenditure is increased from OE1 to OE, and a movement from B to C, that is price is falling from P2 to P3, this point to this point, total expenditure remains same at E, that is movement from B to C, price has fallen from P2 to P3, but expenditure has remains same at OE. So movement from B to C is elasticity is equal to 1. And when price further falls from P3 to P4, that is when the movement takes place from point C to point D, expenditure falls from OE to OE1. So price is falling and expenditure is also falling. So in between C to D, C and D, elasticity is less than 1. And we have also learned what is the relationship between slope of the demand curve and elasticities, we have seen that even slopes are different, elasticity can be same, and even elasticities are different, slopes can be same. And these are the methods of measuring elasticity: proportional method, outlay method, arc method, and point method. In arc method, we measure elasticity as average in between 2 points, of the demand curve. And there we take average of prices, that is average of new and old prices, and average of new and old quantities. In place of P, we take P1 plus P2 divided by 2, and in place of Q, we take Q1 plus Q2 divided by 2. That's it. Okay. Yeah. I think it is enough for this video. I hope you have enjoyed this video. I mean, this video is going to benefit you. Please send your comments, your queries. Okay, and once again I request you to subscribe our channel, like our channel, right? Thank you for watching this video. Goodbye and stay well.